CAD 911, please state the nature of your emergency.
Hey, welcome back to the channel. I was interested in diving into the framing of a structure. And what you see here is Chief Architect. And Chief Architect is pretty amazing software for creating plans for permit. It's awesome, okay? But like with most things, it could always be improved. So first of all, I'm going to show you what this little building looks like. It's a very simple little building. And what I wanted to do was just do a standard common roof with a shed roof over a porch that intersects. And this is common. So this is something that a framer would run into. I don't think trusses work really well here. I've seen it done where you could truss this roof and then this would become a lay-on. You would put sheathing and plywood on here and then just lay this on. But traditional framing would be rafters, and then these rafters would go through and tie together. So I want to show you what Chief does. I don't think anybody in the world would probably frame like this. And what I'm trying to understand, and I think it makes sense, is that the software sees these two roof planes that are parallel as opposite sides of a ridge. And so it drops a ridge in there and tries to make the geometry work. That's the only thing I can imagine. But if I was to generate this and include it in a plan, there's no way. No one frames like this. So what I want to do is help Chief figure out what's going on. And what needs to happen is all these rafters here need to land on this wall, and then their tails are cut off. I'm going to leave this diagram up for a few moments so that you can look at all the components and we can have a common reference. In this example, this happens to be a 10 and 12 with a 4 and 12 intersecting. But as you can see, the same thing applies. The only thing missing in this diagram is the 2x4 that you would rest right here, and it would be permanent, and it would help if you were a solo framer so that you could do all the installation walking along this beam, shooting these in, and then come back and attach each one to the rafter. So pause the video if you want, and if anyone wants this as a PDF, let me know, and I will make sure that there is a shared Dropbox link. And software that can do this, like, let me just caveat this. Chief generated this almost instantly. So for a time factor, this is insane how awesome this is. It's just wrong, and I think we can come up with a way to fix this. So I'm going to show you SketchUp. SketchUp took much longer. I totally, as every bit of this, I have about 8 to 10 hours in this. And, but it's actually correct. It's the way you would frame it. So what I would like to do is propose some kind of, maybe Chief has technical guys that want to get together and discuss how we can figure this out. There's a gentleman named Nathaniel Wilkerson, and he has built a whole lot of plugins for SketchUp. And I used some of his plugins for the foundation and the walls, and I haven't studied his plugins enough to understand how to make them do the roof. And I'm pretty sure this is a very simple roof for him to do. I'm going to turn on the x-ray so you can see the level of detail that is able to be automatically generated through his Medique foundation and his Medique wall plugins or extensions, as they're called. And that part went really quick. And he does like the openings and everything, so it's pretty cool. But the rest of this, since I didn't know how to, make his roof would easily do this 12 and 12, but I don't know how he would do this part of the framing. I just did this manually. And I would like to get together with some of the experts in different software, and maybe we can come up with some kind of way to make it more accurate in whatever platform you want to choose. I'm really starting to like SketchUp because it has complete control over each individual item. And there's not the off chance that I hit auto reframe or auto this or auto that, and a bunch of work I do gets lost. Sometimes that happens. You try to lock it in Chief and then it'll regenerate, and if you didn't do something correct, all of a sudden all your framing's changed and your friend becomes Control Z or Command Z till you back out of that. But this channel is, the focus of this channel is to capture the things that aren't quite right, get with people who know solutions, and work those solutions so that all of us win. All of us are faster, our designs are more accurate, and that's where, if you're watching this video and you have a comment that's helpful or something that you know how to do, please share it. We want to build a channel where people go to find solutions. And we're open to any kind of suggestion that helps make things better. So this was pretty much what I wanted to show. I'll just go over the steps as a framer. The first thing you would do is you're going to make these rafters of the main roof straight, as in not sagging or being bowed. So that might require a temporary purlin all the way across here. And you don't even need to brace it, really. You just need to nail the rafters to a 2x8 or a 2x10 on the layout that they're supposed to be. And then that will make them all even in plane with each other. They'll be straight across here. Then, once that's done, you do the you don't have to do the calculation. You could probably just eyeball this, put a level on here. You could play that game. But I like to calculate from the outside of the wall plate at the height of a plate along the rafter, come up, make a mark, and make the same mark at the other end. And now that all these rafters are straight, pop a line across here, and then put, say, 3 rafters, an outside one, a middle one, and an end one. And that will give me a nice level intersection point to where I could tuck a 2x4 like this, or a couple of them actually, up snug underneath those rafters so that this will support. And you shoot those, this is going to be a permanent board right here. Shoot those in, a couple nails to each rafter. And now one person can set all these rafters, because all you got to do is have them leaned up, either lean them all up in the corner or lean them along the back, pull them up, run them up here, lay them on this 2x4 so they'll be at the right elevation, and then shoot them in as you go, and then come around the inside and line the tops up with the popped line you made, and it should be right on top of that 2x4. And then shoot them in. Then from a ladder, because I don't think you're going to be able to crawl up under there, you're going to do a purlin. And the rules for purlin are whatever the depth of your rafter is, this red thing has to be that. And what I did here is I used an LVL just because I just thought that would be even more beefy. It's not needed. The code is pretty specific about this. And the only reason I put it here is because that's kind of a long span for a 2x6. For if there's a 2x8, I think you get 11'7" for any pitch up to a 12 and 12 in a 30-pound snow load. And all that's in the code. I just know that that's the last one I did up in Linden was that. That was the code. And then, since these are like 2x8 ceiling joists, and I'm going to turn off this plywood, I put blocking on load-bearing walls, because on a good slab, you're going to have a waffle slab where every 10 feet you're going to have grade beams across. So pretty much all the walls can be considered load-bearing. Then you build a wall, a little knee wall, and you snug it up underneath the rafters. So you're taking the load off of this 2x4, which would be sagging the main roof a little bit. And now you're transferring, since all these are nailed into the side of the rafters, you snug it up, you're transferring that load down across these joists. Now, if these were 2x6s, I would say, no, you can't do that because you could deflect your ceiling. But since these are 2x8s, and there's only like 10 feet, and wherever there's a wall, it's got support. I think maybe there should be some blocking right there. Or you could plywood this, or you could even turn this into a beam. You know, you could actually come up here and put a beam across and only let it land on the walls. But in this call where it's 2x8, I'm like, man, 10 feet, that's not going to deflect at all. And really, you're not deflecting because you're nailed in. The main roof is not going to sag. This roof's got a purlin here, so there's no sag involved. This is just like extra. Then, while I was wanting to showcase that, I thought, well, maybe we could do a vaulted ceiling. And that would be kind of cool. And there's different ways to do the vaulted ceiling. On this end, you're going to want a balloon frame all the way up. And then you're going to put in, this is fire blocking, but it's also a sheetrock nailer. So one of them is flush to the bottom of the rafter, and then the other one sticks down so that the sheetrocker has something to nail to. And then these are blocks at plate height just to make it easy so that if whatever sheetrock they're running, if this is a 9-foot wall and they're using 54-inch sideways, then they can go up and they'll hit wood when they go to attach it. When I was in Texas, we never really did lateral restraint, but up here in Washington, they do lateral restraint blocking, and they don't close soffit. So they drill holes in here, call them bird blocks. But this is pretty awesome because it keeps the rafter from wanting to twist. I don't know if that's a big deal where you're at, but it is where we're at. And this is a different way to do like a rake wall, blocking flush to the bottom of the rafter, and then a 2x extending down into the ceiling so that you have nailing surface. And here's another way, blocking in between. This is a little more cutting because you got a lot of notching and things going on there. So that's the other thing. This may seem old school, but I'm going to turn off this, and I believe that. So this is how, when I first started framing, this is how we would notch our rake wall studs. And then we would put the rafter down here and shoot into them. And then, as you can see, it's pretty clean because the face of this is flush with this. And then when you do your subfascia, as you're plywooding this, you come up and you're actually nailing onto quite a bit of the rafter up underneath this 2x that's sticking out here. But I've seen people that say, oh, that's a waste of time, that's stupid. So some people will take the last rafter and move it completely to the inside and just nail it to the side of these studs. And then nail your 2x to the outside. There's just all kinds of ways. It doesn't really matter. If you get good at something, go with what you're good at. Go with what passes code. And I just like this way because it just looks, to me, it looks right because that's how I was shown how to do it. Here's two different eyebrows, kind of. This is one type of return. And here's another. And then there's another third one of this style. where you would hip back, and this is like 8 and 12 pitch, so you'd hip back, same thing, 8 and 12, and make a little hip roof right here. So there's many different ways to do returns. You know what I'd like about SketchUp is I wish there would be a way to label cleanly and bigger, because if I do a dimension right here, the text is really small. I'm sure there's probably text size control, but I guess it's hard to label a 3D model and make it look right, because as you turn it around, your label's either going to hide or it's going to always face you. That might be difficult to do. But I guess it'll just be screenshots or exports to 2D and then label it with a nice clean set of leader lines. That might work. So that's where I'm getting at is Chief Architect is amazing at getting a set of plans together, but it doesn't do this right. And so for now, the workflow for me is going to be Chief Architect to get a 70 to 90% solution. And I don't ever submit this type of drawing for permit, but I do have builders that would really like to have this for their framers, but also this level of detail in some kind of material list or estimator, where I could send them something either in Excel or PDF, and they would have a material list that's exact, because then they can always add their percentages for overage. But stay tuned to this channel. I know we only have a few subscribers, but Larry has friends who are amazing, and he has invited some of his friends to come on here and share what they know. So we're going to showcase them and hopefully learn some things, but also share with you what they know, so that if it's something that you might need, contact them. That's how business works. If we can help each other and we gain some knowledge and they gain some business, I'm excited for that. So I hope this has been entertaining. I don't really know what to do for calculating anything for you right now. All this can be calculated. If I need to do a video where we show how you calculate this, let me know. We can use the Construction Master, or we can use reverse Polish notation in a scientific calculator. We could use CAD. The nice thing, okay, so that's another thing. Chief, the length of the rafters, they measure out to the outside of the roof plane, and that's not correct. And a rafter is measured from the outside of framing to the face of the ridge. And then you add an extra bit for the tail. So yeah, you could call this this entire thing a rafter, but technically this is the rafter length up here, and the part down this way is the tail. So the rafter and the tail are two separate measurements that are part of a single thing. So with that, I keep stopping. So the other thing I'm going to do is, when I get time, I'm actually going to angle this up. I wonder if I have that picture handy. I think I have a folder here. Yeah. I want to share. Where is it? Well, I'm going to have to show you this next time, because I don't have... I'll tell you what. I'm going to hit pause, and I'll be right back, because I think that'll work. Okay, I was able to locate it and track it down. There's a couple things I wanted to share. So in a ceiling like this, you can do something like this. So there's real. And all I need to do is in SketchUp figure out how to draw this hip. And the rest of this is just rafters, and then you can just trim against this hip. So I need to do a little more work, but that's we used to call it a sloped tray. Who knows? I'll tell you, this one thing about framing is a lot of the terminology is regional. And then there was a house down in Texas where we decided to do a custom ceiling. And the first thing we did was traced it out on plywood and cut the shape out. And then on the next piece, we just traced that with a pencil, and then we were able to put wooden blocks along this line. And I'll show you what it became. I'm thinking everybody knows what that shape is. But this exactly represents the state of Texas. And then what it looked like when it was complete. And the builder on this one was pretty good. He had an eye for this sort of thing. It's some kind of crinkle paint, I think they call it, where it looks like it's peeling up on, it's interesting. And Texans are really big for their stars. So, of course, there's a star there. But that's another thing you can do if your ceilings are tall enough. So even if you use trusses, if you go with a tall enough wall, you can drop your ceiling and then you can put pretty cool features in. But stick framing especially, you have so many more options, stick framing, than you do trusses and all that sort of thing. Like in a truss, you'd have, this would all be webbed, and this area vaulted. You wouldn't have any of this space here. But since you have space, you can have storage. So there's that. Here is an actual ellipse. And there's a difference between an oval and a circle and an ellipse. An ellipse has two focal points, one right about where you see the crosshair and one up here. And you loop a string around both of those focal points and out to an edge, and then you just swing your pencil around and it creates this perfect shape. And we did, in fact, I can show you the other side. So if you look, there's light on the right hand side of this picture because there's a window right there, and they wanted two of these. So if you were to turn around and look the other direction, there's this one, and there's a window there. And this is all ICF. This was really fun to work in. Didn't need to brace any of the outside walls because they were concrete. But yeah, they wanted two ellipses, and they ended up putting a ceiling fan in each one. And that whole yeah, so this right there ends up looking like this when it's done. So you get that sloped sheetrock look, and it's just custom. You can do this with trusses, but as soon as you start making custom trusses, they get expensive because they can't reuse the same jig often. They have to reset for each truss, so you're going to pay for that. All right, so this video has gone long enough. I want to do a lot more, but it looks like I just have to get this one off my plate. And there's so much coming. I'm looking forward to reading comments and interacting with people who have either ideas or questions. And we will do our best. The experts that we have on tap are amazing. And if you call CAD 911, if we can't solve it, you're definitely going to have us doing homework, because we will get an answer for you. All right. Thanks for watching.